Thank you for the introduction. I will let me share my screen. Let me go into the presentation mode. And by now you should be seeing my screen. It feels like kind of a flashback to the good old days. Can you hear me? Can you see my screen? All those kind of things. But yeah, well, that times have passed now. So I hope you're enjoying the shared screen now and you're enjoying the conference. Thank you again for having me. Today I'd like to talk a little bit about um, how to make your Java applications a bit more awesome. So of all these things that I'm going to be mentioning, it's not that you really need to put them all into and implement them at once. And it should be enough to at least do some of those things, and that will already make your applications a little bit better. And I would like to talk a little bit about how and show you some examples. I will also show you some code at the end and the repository to a lot of those things that I'll be talking about. It's open on GitHub already, so you can have a look there. I will be pushing some small updates, so the things that you will be seeing on live now, there's maybe some changes that haven't been pushed, but it's usually just a small things that needs to be polished a tiny little bit, and I'll push probably today or tomorrow or something. With all that out of the way, we should start probably our presentation. And by the way, I'm not sure how it works with the questions and everything, but if you have a chance to interrupt me and push questions to me or anything like that, that's really great. If not, then we'll do it at the end. It will be up to the moderators, I guess. But if there are any questions and if they're coming in as I speak, it's just more than welcome to actually interrupt me as well. Let's do it more, if we can, let's do it more of a conversation than just me broadcasting some stuff to you. All right, so my name is Rustam. I'm joining you all from Oslo, Norway. I'm a Java champion. I'm a Google developer expert for cloud, so I talk quite a lot about, and I work quite a lot about with Java and cloud and architecture and things like that. And well, this is quite right on topic for this topic as well, for this talk. So before I do that, I would like to do a little bit of introduction and go a little bit into, give you a little bit of context. And some of the things that I'll be mentioning, I'll be talking about things like Jakarta, microprofile and all these kind of things. But, what is a Jakarta EE? So it's kind of funny. I do this with a live audience. I usually ask like, okay, how many of you have used Java EE? And then there will be some hands. And then they're like, okay, cool. How many of you have used J2E? And there will be some other hands. And then you say, okay, how many of you are using Jakarta EE? There will be some other set of hands. And it's kind of funny because if you kind of raise your hands for one of them, it's most likely that you used all the other ones as well. And that's a little bit of the context. So, all these things had the different names throughout the history of Java, but it's basically it's kind of a different name to a similar technology, which has been evolving quite a lot and has been adding new features and new things along the way. As you can see, there's like at some point we got dependency injection, some other point we got more like JSON stuff and WebSockets and stuff, and then we got some more stuff, and then it changed its name to Jakarta EE and became under the Jakarta umbrella. And now we have release of Jakarta EE 10 and then 11 and all this stuff. So that is what is Jakarta EE kind of very, very quickly. What I'll be talking about and a lot of the things I will be mentioning, it's just a part of that. So you have Jakarta EE 10 platform in general, which is a big thing that you see on the screen here. A lot of it is grayed out on purpose. So just to show you that it exists there, but you don't really need to kind of focus on that right now. You can go and have a look. There are some things, there are packages. So Jakarta EE is basically a bunch of libraries and packages and stuff that let you do some extra stuff. Extra things like, I don't know, there is things for emails and things for faces and security and servlets and, all this kind of stuff, authorization, activation, batch, all this kind of stuff. But we don't think about this for now. So for now, we'll be thinking about CDI, JSON, annotations, interceptors, all this kind of stuff that you see under the core profile for Jakarta 10. It's been also a work to separate it in different profiles. So you have a kind of full profile, you have web profile, and you have core profile. So core profile, that's the one that we're talking about here. And this is a part of the things that typically you need for microservices. And modern Java applications, what is a modern Java application? It's usually a Java application that either is a bunch of microservices or talks to a bunch of microservices, or maybe probably both. And also you need to communicate over some kind of REST interfaces or RESTful, REST-ish interfaces. You need to be able to support, you need to be cloud native, what we call, and that doesn't mean that you really need to run things on a cloud, but it actually means that you are, I don't know, you can call it cloud ready, I guess, but the point is that it supports a lot of the things that are quite common in the cloud world. On top of that, so if we go back again, you see the Jakarta core profile? Yeah. So now I would like to talk, now you see it's a little yellow box at the bottom called Jakarta 10 core profile. Then you have all the other things, like extra things on top of that, things like telemetry, open API, so, way of exposing and documenting your APIs. Things like REST clients, the way you talk to another RESTful interfaces, other microservices, other things like config, fault tolerance, metrics, all those kind of things, health, that we'll be talking a little bit about as well. And that comes on top of Jakarta 10 core profile, and that is a part of something called micro profile. What I'm going to be telling, I'm going to be showing some code based on this, but there are other ways of doing that. There are some other stacks, there are some other things, and I'm pretty sure that most of the things that I'm going to be mentioning here, you can do in those as well. Things like something Spring related, Spring Boot, Spring, all these things with Spring. You have also things like Micronaut, all the other things. You should be able to do a lot of those things that I'll be mentioning. But now I'm introducing the stack I will be using in my code examples and stuff like that. All right, so with that out of the way, it's important to mention also that the things that we have mentioned so far, micro profile, Jakarta and all those kind of things, it's actually a bunch of specifications. So it's a specification that describes how things should be behaving, how it should be, and so on, so on, so on, so on. And it's up to others or up to providers to actually implement that. There are some reference implementations, there are some other implementations, and so on, so on, so on. But it's actually up to others to implement. That also means that there are possibly several implementations of the same spec, and that is probably can be a good thing, can be maybe a little bit less good thing, but in most of the cases, especially for example in the world of microprofile, it's a very nice thing, because that also means that you have several runtimes. We used to call them app servers, app servers before, but runtimes is a proper name to call them nowadays. And different runtimes will have a little bit different possibly different implementations of that. And then so that also means that if you may find a bug, may find some kind of something not implemented, something is missing, or it usually doesn't happen anymore. It used to be much more common when microprofile was kind of very new and fresh and everything, but nowadays it usually doesn't happen. But the idea is, if it happens, that you can actually switch to another implementation and see how things behave and work otherwise. All right, let's talk about those 5 things that I've been talking about. And I call it kind of non-functional requirements, because it's usually things that are not really part of the requirements from your boss, your customer, whoever is asking you to implement something. If you're implementing things for yourself, well, I guess you're your own boss, but still, it's not functional requirements. It's not like, well, this website or this backend should be able to do I don't know, bank transactions. It's not that. It's like it's all those things that should be there anyway to make your life easier. And one of them, and one of the kind of most key elements of that, especially in the world of microservices, it is things like fault tolerance. What fault tolerance really means? It means you need to think about what happens when something you rely on fails. So let's say you're using a microservice that is outside of your control, or maybe it's even within your control. Doesn't matter. Let's say you're using a third-party web service for weather forecasts. Okay, cool. You're using that, and one day something is wrong, something fails, internet connection is down, or something else is happening, and then it's down. What do you do? Well, what you can do is to fail miserably and just die. Your application just dies and lies in a corner and just like spits out 500 errors and 400 errors and all kind of the Christmas tree of errors. Or you can actually fail somehow gracefully. Maybe you can just deteriorate the experience for the users a tiny little bit and actually tell the user, hey, you know what, you're not getting that weather thing, but you can get all the other things because something is failing. But how do you do that? I mean, because one of the things, though, okay, let's talk about first why. The first one is the idea, or why you want to do that is, like I said, one of them is that your application crashes if something fails. You don't want that to happen. Or maybe you want to, if it fails, if that weather forecast is failing, maybe you want to switch to some kind of backup solution. Maybe you want to switch to something that is less accurate but more reliable, maybe, right? You have another service that, well, kind of sucks. I mean, it's really not really that accurate, but hey, it's reliable. Like there's nothing, it just works. So maybe you can switch to that one without users noticing it for a little while until the other one is up and running. Or maybe you want to make sure that you do not DDoS your applications internally, because if you look at a lot of postmortems or analysis of applications that has been or bad things that has happened throughout times, it has happened quite often that you have had something failing on your network. All the other applications try to reach that, and they keep on retrying and retrying and retrying, and the amount of those applications trying to retry and get some kind of backend service increases, and at the end you kind of manage to saturate your network is overloaded, and everything else stops working, and then it just kind of pulls everything with it down to a total standstill. And you don't want that to happen either. So the fault tolerance is an important thing to be able to do this kind of things. And how do you do that? Well, the spec for this particular implementation, like spec for fault tolerance for microprofile, you can find on this tiny little link down below. It's kind of on purpose. It's very, very little font, but you can just, worst case, just Google it or ask me to share the link and I'll share it. It's the spec for whatever you're using, if you're not using microprofile, will be a little bit different, but you can expect very similar kind of things, because you really need to have things like full timeouts. So, if something is not responding within a specific period of time, you want it to just time out and do something else. You want to specify how you want to do retries, or how you want to do circuit breakers. So, I mean, for example, maybe you want to implement some kind of exponential backoffs for retries, or you want to specify a fallback endpoint. So, like I said, one weather service precise but not very stable, the other one less precise but very stable, and then you can just specify a fallback and just fail over to that one. Maybe that will be your thing. Maybe you want to do that. So you can just do that. And the cool thing with Jakarta E, and that way, micro-profile approach of doing that, it's that you do all that with just annotations. So it's actually just annotations on your endpoints, and then you can just do that. There's also things like circuit breakers that let you stop doing whatever you're doing after a certain things that has been met, some certain requirements, certain certain things that you set in your code. Like I said, if you want to read more, just look up the fault tolerance spec, and then, but we'll see some code examples as well in a little bit. This is the kind of the static code, if you can call that. So this is basically screenshots, but I actually have right behind that presentation, there is an ID with all that code live as well that we'll be looking after I've gone through all those 5 things. But just to give you an idea, so here we actually, what we're doing here is actually we're defining a REST client. So we're actually telling that, hey, this is a service. It will be using something on the backend. So it will be calling some other services. And for that, we need the REST client. So we define the REST client. We define the path that it will be responding on. So API/something, and API/message should do one thing. And then API/message backup should do something else. And that's how you also create a fallback method as well. So if this first method /message fails, you can actually define a fallback, and then it will actually go and call that fallback things. The paths that you see here, that is actually paths to the REST to the REST backend. So we'll see that in a bit, but that's basically will be localhost 8080, since the base URL for REST client is localhost 8080/message /API/message API/message backup. Okay. On the backside, on the back end of the services, so we'll be calling message and backup message, or message backup, right? So on the other side, it will look like this. So this is actual web service that is being called in the background. And here I just had tried to implement instability for the first one, for the message, just to make it kind of randomly fail at some points, but still controllably randomly. So what I'm doing a very, very, very scientific method of failing. I just roll a dice, and then if the whatever I get from the roll is divisible by 2, I say it's a great success. And if not, then I just respond with a some weird error. Actually, I don't even say what it is. I just say something really, really strange. That's usually what you can expect out there on the interwebs. You know, you not always get a very proper messages. And the backup service is simple. The only thing it just says, it actually returns a message, and it says actually backup hello instead of hello there. So then I know that at some point I actually failed over to that. We'll see that in live in a little bit. Okay, next thing. So we talked a bit about fault tolerance. So we talked about what happens when things go bad. Now let's talk a little bit about how you can actually measure things if they're going or about to go bad, and do something about it. That is health. So now we want to be able to see what is happening inside your applications, because, you know, think of it of this like this. You have a cloud native application. Your application is running somewhere in a container, somewhere on the cloud, somewhere within another container and another container and another network and something. And there is no way of, like, you know, opening that little box of a container and picking inside and actually looking at, oh, how is my CPU doing? Or how is my... Back in the days, we could do that easily, right? You would have a, I don't know, a machine, like a Linux machine or Windows machine or whatever, running some kind of application server like Tomcat or something. You could just log into that machine, check the stats, check the CPU, check the memory, maybe set up some metrics with alerting and stuff like that, and then you will just get that. Now you have all these containers. Now you have to be able to do that a little bit more smooth. You can't do it manually anymore because, many reasons. You have many more applications. You have many more layers of abstraction. You have a lot of those kind of things. So you want to expose that health stuff more automatically and in a more standardized way. And I have a very, 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 very bad pun for this. What's up, app? Yes. I'm kind of not very proud of it, but kind of a little bit proud of it anyway, because it's so bad, it's good kind of thing. But that's a kind of a good way of remembering why and what you use it for. Most of the cases you need to use this kind of health to understand if the container you're using is it up at all? Like, is it alive? Well, I know it says it's up, but is it actually up? Is the application inside that container is up? And should I is it ready to receive requests? Because if you think about it, your application is now running inside a container that needs to. So when you deploy a new application and start routing it, traffic to it, you can't just route it, traffic to it right away, because first something needs to run somewhere to a container registry and copy that image of a container. Then that container needs to boot up. So whatever tiny little layer of operating system like thing needs to actually to start up. After that is done, then your application needs to start up inside that container. And after that, it can tell whatever is doing the routing, like some kind of load balancer or whatever, to say, hey, you know what? Now I'm ready to receive requests. I'm like, all systems go. I'm happy, and just give me some network requests. And to do that, you need health, because and also you need that for scaling. So because all that I've described can also be happening when you're scaling horizontally or up or down, actually, because when there is too much requests, you can set up it that way that it creates another copy and another copy and another copy of containers. To know when to start routing traffic to the new ones, you actually need to know when it's up and running. To start taking them down, because now you have less requests and you need to scale down, or you want to scale down, you also need to know if how is your application is doing, if it's done processing requests and stuff like that before you can scale down. So all these kind of things you really need to know, and you need to expose that to a platform that will be doing that for you automatically, because you don't want to do that manually either. There are, for health, there are three annotations that we have for microprofile health spec. That is called readiness, startup, and liveness. Again, you will find something very similar in whatever you're using for developing your microservices, even if you're using it with other languages, other JVM languages, or maybe even totally different languages. You should be able to find something similar, or at least a similar functionality, because this is being used by things like Kubernetes and so on and so on. So readiness, like, are you ready to actually serve and receive requests? Startup, well, have you started up? And liveness is basically, are you alive? Are you doing fine? Are you okay? Another thing that we really need to talk about, and it's kind of in the same direction of looking inside the little box of your application, and that is more about metrics. So now we want to actually expose, by the way, when it comes to this readiness stuff and startup and liveness and everything, I'll show you some custom code that can actually, so you annotate with readiness, and you can actually write your own custom code that does whatever it's supposed to do, that's specific to your application, to actually tell it's ready. And same with startup and liveness and all these things. So I've implemented some custom things that you can have a look. And it's very simple. It's made to be a demo-like code, but you will be able to write your own more advanced stuff if you have to. So metrics is in the same direction, like I said, but the idea here is that you can create even more custom stuff to measure things. So you can create a custom application metrics and expose those to the platform. So, you know, things like Prometheus or whatever your cloud platform is using for alerting and observability and all this kind of things needs to use. You can expose it and it can be just consumed from there. And it's the other cool thing is that it's basically will always return all that information through a standard endpoint. So for, again, if I jump back, for health, it's /health. And for metrics, it's basically /metrics. And then you'll see all the things there. Let's do a quick, just a very quick demo. So here is my application. So I'm running it there. But if I go to health, okay, let me zoom in a little bit so you can actually see what's going on. So you see I have my own health stuff, and I actually implemented some custom things. So I'm checking for if my backend for my backend, because this is a web service, right? So technically it's a backend. That's what we usually call it. It's not a web front end, but think of it as a web service front end. And then I have another one that is actually being called from this one further on. You'll see that in a second. But I have also checks for this and things like that. That's health. And the metrics, yes, looks like this. You see, it's a wall of text. It's not really meant to be for, I don't know if we can say human consumption, but you know, it's not very readable, right? And this is my front end backend service for metrics. And if I switch to, I believe that's 82. Yeah. So here I actually have another metrics for my backend service. And here I created some custom metrics that do some counting. So if I actually, so if you look, we have 3 failovers and 6 total calls. So if I go back to localhost 8091, hello, and refresh a few times, you'll see that like it was 3 and 6, and if you refresh it now, it's 5 and 14. So it's been some of them have been failing, and some of them. So I actually run the whole thing 14 times now, and 5 of those failed, for example, right? And that is very simple but custom implementation of a metric. Let's go back to the presentation, and then we'll be back to see some code in a second. Why do you want to do that? Well, like we've seen already, you want to measure some custom parameters. You want to measure, for example, how many times a backend is being called. That's kind of a very basic thing to measure. Maybe you want to do that. Like, how popular is my thing? Or how much pressure am I getting? How much things are failing, but with failover and stuff. So users don't notice, but I still need to know. And you can, like I said, you can create all those things specific to your actual application. So it's not something that you'll get out of the box because, well, your application is different. Your application is a unicorn. A simple way of doing that. So like I said, it's a very simple. The simplest way is implementing a counter. So you do a counter, you give it a name. Not clicking on the slides. That's who would have thought. You need to provide a name. You need to say if it's an absolute value or not, and you also need to provide like tags and stuff. So, for example, in our case here, we have a tag called purpose, and value was failover and purpose total. So that was my tags. That was very creative names, I know, but you know it's a demo app, so I guess it's fine for this. The way it's like I said, the way it's being exposed is through /metrics. All right. So far, we've seen things that I have been referring to, with annotations and code and things. And I've been talking a lot about Jakarta EE and microprofile and all this kind of thing. Now I want to talk about something totally different, because so now I want to talk a little bit more about a thing that's is typically is a different system. It's a different application. It's a different kind of animal. But you would like to have that in your application. So you would typically it's called feature toggling services or feature toggling applications that you would have next to you. The dumb way of doing that, or sorry, no, probably the simple and not so good way of doing that would be to create an enormous amount if else's in your code that you will need to clean up later. You'll get a lot of headache, hence the name of not very smart way of doing that, because it may feel fine right there, but you still need to clean up. You still need to, remove that technical backlog, technical debt. And it's not that fun. Especially when you have systems that can do that. So I'm going to show you one of them, and that is called Unleash. And the reason I'm doing that, I don't have really any affiliations or anything with it, but the reason I'm mentioning it, it's because it's actually open source. Well, they do have a managed version that you can pay for and so on and so on. We're not going to talk about this one. This is basically a thing that you can pull down in the containers and actually run it on your own instances and on your own machine or in your own cloud or whatever, and do that. And it's for free and open source. And that's why I'm actually mentioning them, because otherwise I try not to mention commercial products if I don't have to. So why do you want to do that? It is all about making features available, and there can be many reasons for you to want to do that. The most obvious one is, well, obviously you want to turn off and on features. Why do you want to do that? Well, it depends, because sometimes you want to turn on and off features based on geographical location. Like all people in Norway should see one picture, and all people in Germany should see another picture. All people in the US should see a third different picture, or different kind of login, or a different kind of I don't know, text, language, any kind of things like that. Maybe language is not really a feature kind of thing, but anyway. Another reason for that can be also gradual releases, because sometimes you just want to say, you know what, we've created this feature. We don't know how it's going to behave in out there in the wild. We want to make it available for 10% of our users and see how it behaves. If it fails, okay, fine. We'll decrease the number of users it's being available to, or turn it off at all, fix it, and then try again. If it behaves really nicely, we'll make it available for 50% of our users, or 70, or 100, or whatever. So gradual releases, things like focus groups and stuff like that. Another good idea of doing that is also, for example, trying to hide partially implemented features. So imagine somebody on the front-end side actually delivered everything, and the back-end team still not done with their backend, and you have to go for a release. What do? Do you uncomment or comment out all the things in the front end and just release it and then fix that later? That's not probably the best way of doing that, but maybe you can actually add a temporary feature toggle for the front end thing, and then you can actually just toggle it live in the production whenever backend is deployed and it's fixed. And then you just toggle it, and all of a sudden it's just available for everyone without you needing to deploy anything. Doing it by hand is not really an option, like we talked a little bit already. I mean, it is an option, but you don't want to do that because you'll have a lot of headache. Another way of doing that would have been putting things in the config files and just using config for that. it's still not a good idea because, usually most of the times to refresh config files and reread information, you need to restart your application. How do you do that? Well, then you will probably have some kind of downtime, and then you'll have, it's a bit of a mess to not being able to automate all this stuff, and doing it in a cloud native way without downtime or with minimal downtime and all these kind of things. It's probably a good idea to use the tool. So the one I will be showing you, it's called Unleash, like I said, and yeah, we'll have a look at that in a second. The way it looks in the code, it's basically you just say you create a Unleash object earlier somewhere in the code, you make it available, and then you can just say unleash.enabled is enabled or yes or no, and then you provide a variable name. And that's all. That's all you have to do. This is how I implemented it's a feature or a bug functionality, because of course we all need that in our application. So I have created a feature toggle. So if you ask if that's a feature, it actually tells you, well, no, it's actually a bug. But if you enable the chaos variable in our feature toggling service, and if chaos is set to true, well, of course, our bug suddenly and magically becomes a feature. Isn't that amazing? The way it looks in the user interface for the Unleash, that's how it looks. You see on the bottom there. So you can have basically different environments like development and production and so on, and then you can enable and disable the same feature in different environments as you wish. One last thing I want to talk a little bit about before we go into and dive into the code is it's a kind of bucket of things that didn't fit on all the other things. It's talking about environments, configurations, infrastructure, all these kind of things. And one of the most important things, if you really like out of this fifth category, if you want to leave this room or leave, go on with your day today and want to take one thing from the last category with you today, that is do not even think about doing ClickOps. So if you have some kind of stuff set up, do not try to put, doing ClickOps in the cloud environment or, whatever environment that you're deploying in, because you should try to automate it one way or another. There are ways of doing things like, code as infrastructure as code, and all this kind of things that will help you to automate, but also they will help you to document, really, because now you have a documented way of doing that. If you've done ClickOps, there will be 3 months that will pass and your application will not be working anymore, or you will need to deploy a new version or something, and you will probably have forgotten all the things that you had to click to make it work. And in 3 months, when you have to do it, you have a problem. So do not do ClickOps. Try to automate, try to script all those things as much as possible in one way or another. I'm not going to tell you how to do that. Do it whatever works for you, but just do something. Don't do ClickOps. Why do you want to do that? Well, like I said, it's reproducible. It's also documented because now you actually know exactly what's happening, one step by step. And it's also, well, obviously it's automated, so you don't really have to do this boring clicking things all the time. You can just rerun the script. The downside of this is that you need to actually maintain this. It's not just write once and it will be working forever, because things change, environments change, your cloud providers introduce new features, your application will be different, your versions will be different, and so on. Maybe you will need to maintain it. Most likely you will need to maintain it. Most likely you'll need to do some small changes, but still it will be so much worth it. I've done so much debugging of ClickOps, things that we forgot to figure out how, and then it's horrible. And then worst case is not documentation at all. A little bit better case, but still very confusing. It's like really long readmes with many steps of things you need to do. That kind of sucks as well, because you'll probably, if it's not automated, you'll do some errors, because we humans do make errors as well. Solutions to that, well, infrastructure as code or Terraform, Pulumi, all these kind of things. For doing configuration stuff, there is actually another spec called microprofile config that lets you create config files in a nice way and actually read those config environment variables and config variables, variables out of config and do things. And when it comes to infrastructure, I want to say, again, your mileage may vary. It will be different for your application, most likely, but you need to think about what level of things that you want to deploy on. If you want to do a VM or if you want to do a serverless application, are you going for a platform as a service? Are you going for infrastructure as a service? Do you need Kubernetes? Maybe you do, maybe you don't. Do you want to do like Knative and serverless kind of stuff? It will be different, but most likely you will need to at least think about and do an active choice of, do I really need X? Like, I'm going to deploy a tiny little application. Should I go serverless or should I actually do a 3-node cluster thing of a Kubernetes installation and everything? How much will it cost me? Things like that. Think through that. Maybe you're so special that you need just a special VM. Maybe your application is that special. Maybe it's fine. Maybe it's not. Maybe you can just run it on a public cloud with serverless and stuff. All right, so let's show you some demo stuff, and then I will I'll give you a quick introduction of how it looks like. You've seen a little bit of what I've been talking about and showing you a little bit already. I think we have 4 more minutes, so that's fine. If you have any questions, still please ask them. There is a chat. Let's see if there is. Okay, there are some questions. That's really nice. Mohammed has been asking a lot of questions. That's great. Okay. Yes, I will. Mohammed, you've been really active. That's amazing. I will share the link to the microprofile thing in a little bit when I'm done. Thanks for the drawing comment, Jonathan. Great to see you here. And okay, I'll do the chat things since we have just a few more minutes. I'll do chat a little bit afterwards, but I will. I'll do that in a second. But okay, let me show you a little bit of a demo first. So the way it works, we have an endpoint called hi and feature, and for that hi endpoint, we actually have a backend service that returns you a message, and that message is being returned through an API. So API message, API backup message for this kind of stuff. We also have the same hi and feature endpoints for backend service, just because it was nice to have one. It was kind of copy pasting first, but then I thought maybe it's nice to keep it. Feature and chaos, and those are the toggles that we're using for feature toggling service. And the feature toggling service here is at the bottom here that is actually serving those things, right? So back to the code. So the code that you'll be seeing, so the same drawing that you've seen in the presentation, you will see it there as well. This is actually at the README file. You will also see a bunch of endpoints that you can be using here as well. As you can see, I am running here. Ignore the first some Redis stuff that I was playing around with for something else, but the bottom 4 instances are the ones that we're actually running in a Docker Compose, or actually Podman Compose for this case. Okay, let's have a look at things. So if we go to the beginning of this file, so the cool things, we've seen health, we've seen metrics. I want to show you some. Let me see. The moderator is getting back online, so I guess it's my cue that I'm getting booted very soon. No, that's not the one. Sorry. I have this one. So this is the one, the wiki is the one that is actually really interesting. So the things that we've been talking about, you will see here with direct pointers to the code. So fault tolerance, health, and things like that. So for fault tolerance, we've seen this piece of code, right? It's the front end of our backend service where we actually define all this and we define failovers and stuff like that. The actual backend looks like this. In case you wanted to understand how you set up a unleash config file, this is how it is. You basically need to create a object where you define the URL to your server and the instance IDs and keys and stuff like that. And when you've done all this, it will be available. As you can see, I'm using an insecure token because obviously it's just local environment, just on my own machine. But if you go production, please don't do these kind of things. Of course, you should not do this kind of things. I mentioned health checks. Oh, this is fun. Okay, let's see. Response times. So when you implement your own stuff, when you actually implement your own probes, this is how you do it. You do liveness, add liveness here, and then you create a class that needs to implement health check, and then you create your own code. So for this one, I am actually doing a liveness check that checks for response time, and I'm just doing a very simple thing. I just take start timer, I run a request. If request takes longer than 3 seconds, I give an error saying, you know what, critical service has stopped responding or it's very slow. And if it's less than 3 seconds, it's fine. It just works. For example, another example would be response codes. You just do exactly the same thing. You just create a liveness health check response code class, again, implements health check. And here you just basically send a request and look at the request response code that you get back. So if it's HTTP 200 or anything else. So if it's not 200, then I just say, well, critical services stopped responding again. A quick demo of localhost 4242. Nope. There we go. Let's zoom out. Yeah, don't do that. Zoom out. Yeah, so I have a chaos variable here. It's on, and that's the reason why I keep on getting the failovers. 1/hi. So I'm actually getting backup hellos sometimes, right here. If I go, this is the last thing I'll probably have time to show. But if I remove it just here, it's in a different container, different application, right? If I remove it and keep on running this thing, it will never fail again because now it actually has read that the chaos feature is not being used and it's not gonna. So it's the same thing will be happening with feature. So it says it's a bug, right? No matter how many times I refresh it, I turn on the feature thing, and soon yeah, well, it has to be a feature bug. That's right. Create new feature, create. Where are you now? We are go away. We're gonna turn you on in development. So now, within like 10 seconds, we should be seeing, yes, now it's feature. So there you go. So this is how very simple that you can control and toggle features in the environment. And all that code that you've seen so far, it's on GitHub. It's on this link. So my last name and then 5 features talk demo. So you will see most all of the code actually you've seen so far. I have some code that I haven't pushed yet, but it's for a different thing. It's more about content negotiation and stuff like that that I will be posting, and I'll probably create another blog post and talks about that as well in a near future. With this, I would like to show you kind of one last slide, and that is a slide of where you can find me, and say thank you all for joining me for this presentation. I'll try to answer all the questions in the chat after this. So you have also the link for the source code as well. I'll share that copy link in the presentation as well, in the chat. So thank you all for coming, and thank you all for listening. I'm happy to stick around for a little bit and chat with you.